Okay, so good morning everyone. So welcome to the new video about GED test questions, all about science. So these questions in science is more on diagram based questions. So you will base in getting your answer from the diagram shown. Okay, let's take a look on this. Let's have this one. Study the diagram. So the diagram or a container contains the same amount of volume, which is 70 ml, and different amount of temperature. So the question asked here is which of the containers holds the water with the highest average kinetic energy? So in energetics, as we all know that higher the temperature has the higher average kinetic energy because the molecules move faster in a container with a higher temperature. So, which of this diagram or container has the highest amount of temperature? So, X has 80. Okay, so meaning this is the highest temperature here. So, Baker or container X is the answer here. So B is the answer for this question. Let's take a look on this. So this one is a pie chart about the US energy consumption by energy source in 2012. So basically this one, it is all about the energy resources that we have, the renewable and non-renewable energy. As we all know that renewable energy is energy that we can still use. Okay, so we cannot run out of resources on that, while the non-renewable is it takes time to be renewed, or we have to save that energy for future use. Okay, because time goes by, we will run out of that energy resources. So example of that renewable is petroleum, natural gas, and coal. And the renewable energy is the electric power, then geothermal, wind, biomass waste, wood, hydropower. Okay, so let's take a look on the questions, but we will base our answers to the questions here. So according to the energy consumption report of 2012 by the US, Energy Information Administration, the most utilized renewable energy resource in the US is, so it talks about the most used renewable. So we will just look on this phase, okay? Not on this because it is non-renewable. Okay? So the hydropower is 30, the solar is 2, geothermal is 3, and the wind. But they put it in general, the biomass, because biomass waste is a biomass. Biofuels is also a biomass, and then wood is also a biomass. So basically, biomass has the highest or the most utilized renewable energy resource in the United States for 2012. So the answer here is biomass. Let's have here. According to the Energy Consumption Report of 2012 by the U.S. Energy Information Administration, what percentage of energy used in the United States is from fossil fuels? So fossil fuels is a non-renewable energy, and fossil fuels includes coal, natural gas, and petroleum. So if we total this one, this is fossil fuels as well, and fossil fuels. So if we're going to add the coal, the natural gas, and petroleum, 80, 27, and 36, we come up with a total of 81%. So the answer here is the 30 or 81%. Let's have here. So it's now physics. So a swing completes a back and forth cycle every 2 seconds. What is the frequency of the swing? So frequency refers to the number of occurrences of a periodic event over time and is measured in cycle per second. So meaning in computing for the frequency, it's just simply the cycle over time. Since here it's just one cycle, the back and forth cycle every 2 seconds. So one cycle over the time, which is 2. So meaning 1 divided by 2 is 0.5 hertz. So the answer here is letter A. Hertz is a unit of frequency. Okay. So this one again, two anchored boats bob up and down, returning to the same up position every 3 seconds. So this is the time. When one is up, the other down, the other is down. Okay, so this 8 from here to here is the wavelength. Okay, and then the period here is 3 seconds. So if we're going to compute for the frequency of this, it's a cycle per time or 1 over 3 seconds. So that is basically 0.33. So this is now the frequency of the two anchored boats. And this is the wavelength. Okay. Let's try to answer the question. There are never any wave crest between the boats. Calculate the speed of a wave. So in computing for the speed of a wave, it's frequency times the wavelength. So we all know that 8 is the wavelength here. Okay, 8 meter. So 0.33 is the frequency times 8, which is 2.67 meter per second. So letter B is the answer on this question. Consider this diagram. So we have here a wavelength, okay? So this is a wave, and part of a wave is the crest or the highest peak. This is the example of crest, and the trough is the lowest peak. This is the equilibrium, okay? And then this is the wave. So the wavelength is the distance from crest to crest or trough to trough. So this is a crest and this is another crest. So the measurement of crest to crest is the wavelength, or the measurement of trough to trough is the wavelength. This is a trough and this is also another trough. So this is also a wavelength. Okay, so the wavelength of the wave in the diagram is given by the letter. So what letter is the wavelength here? It's letter A, this one. Because wavelength is the distance from the crest to crest or trough to trough. So A is the answer here. Amplitude of the wave in the diagram is given by the letter. So we all know amplitude is the distance from the rest of the crest or from the rest of the trough. So meaning it's the measurement from the equilibrium to crest or from the equilibrium to trough. This one from equilibrium to crest, that is the amplitude. And from the equilibrium to trough, that is another amplitude. So meaning on this diagram, this one, letter D, so letter D is the answer on this question. Let's have here. So we have here the directions, north, south, east, and west. And according to the diagram, a physics teacher, which is this one, starts from a point and walks following the arrow path and the distance and the direction show. So meaning the physics teacher walks 4 meter east, then 2 meter south, then 4 meter west, and 2 meter north. So meaning the total distance of the physics teacher is 4 plus 2 plus 4 plus 2, which is 12 meters. And then the entire motion lasts for 24 seconds. So the teacher walks the entire path for 24 seconds. So the speed of a teacher is, as we all know, speed is the distance over time. So the measurement of the distance over time. So the total distance of the physics teacher is 12 divided by the entire motion for 24 seconds. So 12 divided by 24 is 0.5 meter. So 0.5 meter per seconds is the speed of the teacher. So how about the velocity of the teacher. So as we all know, the difference between speed and velocity is the speed is a scalar quantity which measures only in magnitude, while the velocity it's measures in magnitude together with the direction. So meaning we will look on the directions here that the physics teachers walk from the entire path. And then the velocity is measures in displacement over time. So if we were going to look on this, and the velocity of the teacher is, if the teacher starts here, going here, and going here, so the teachers end up to its starting points because this is the starting points of a teacher, and then he ends up walking on the starting point. So meaning the entire path of a teacher has zero velocity. So 0 meter per second is the velocity of the teacher because velocity is displacement over time, and the displacement refers to the change in position. So the physics teacher didn't change its position. He just entirely walked for 12 meter. Mhm. So that's why it's 0. So that's 64. If a cyclist in the Tour de France travels southwest a total distance of 12,250 meter in 1 hour, what would the velocity of the cyclist be? So 12,250 meter is the displacement here, and the time is 1 hour. So if we're going to convert the time to seconds, because it is in seconds, so that will be 1 times 1 hour is equivalent to um 360 minutes. Okay. And then times 60 seconds in each minute. So that's why it's 3,600 seconds. So 12,250 meter divided by 3,600 seconds, which is equal to 3.40 meter per seconds, and it is in velocity. So as I discussed earlier, that velocity measures in magnitude and direction, and the direction here is in southwest. So 3.40 meter per second southwest. So B is the answer here on this question. Let's have 76. So what is the net force acting on the object shown in the diagram? So we have here two opposing forces, the force to the right and force to the left. Okay, so 15 Newton plus 10 Newton on this part, and then 25 Newton on this part of a force. So they have equal in magnitude in opposite direction. So what will be the net force acting on the object? Since they have equal but opposite direction force, the force will be cancelled out. So meaning it will become 0. So 0 is the answer for 76. Let's have this one. The before collision and after collision, or the collision of the two objects. So we have here mass 1 is 1 kg and the mass 2 is 0.5 kilogram meter per second. So we're talk about the objects. So the before collision, they move on the same direction. Okay, going there. But after collision, they collided. The one mass 1 of 1 kg and the mass of 0.5 kg. So the velocity here is question mark, and here it's 1.33 meter per second. So after collision, after the collision, how fast is the first mass moving? So here it's 1 meter per second. Just simply divide it by 133. How fast is the first mass moving? So it talks about what would be the velocity here after they collided. So meaning we have to simply add the total mass, which is 1 plus 0.5, which is 1.5. And 1.5 divided by 1.3, that is 1.335 meter per second. So the answer here is letter C. So that is for the questions here, diagram-based questions in science. So see you on the next part of the questions in GED science test.